chapter 3 test. All right, and so for the first question, we have what is the instantaneous rate of change at x equal 2 given the function? So what we have to do here is we have to find the derivative. So in order to do this, we have to apply the quotient rule. So it's going to be x minus 1, and that's not going to be the derivative of that. And then we're going to do the derivative of x squared minus 3, which is just 2x minus, and then we have the x squared minus 3, and then the derivative of x minus 1, which is just 1, and all of that over x minus 1 squared. So if we just go through the simplifying this right here, we get 2x squared minus 2x minus x squared plus 3 all over x minus 1 squared, and that will ultimately simplify out to this. And then if we plug in 2, that's a little mistake right there, but I did plug in 2 to the original equation. As you can see, 2x x squared, as you plug in 2, it gets 4, and 2x there's 4 as well if you plug in 2. So this is 2 right here, as the question states. We have to find the slope at 2. So if we plug 2 in there, we'll find out 4 minus 4, 0, 3 over 1, it's just gonna be 3. That is the correct answer for that problem. All right, moving on to the next problem. We have if fx equals negative sine e to the negative x, then the derivative of that, and we just have to apply some basic rules here. So we have the original function right there, and then we know that we can apply the coefficient rule, so we can bring out that -1, and then sine, the derivative of sine should be cosine, and then we apply the chain rule to e to the negative x, so that'd be ln e times e to the negative x times the derivative of negative x, which would just be -1, and of course ln e is just 1 as well. So simplified out, it'd be e to the negative x cosine negative x, and that is the answer that we have right there. Moving on to number 3, an equation of the line tangent to the graph of y equals x plus cosine x at the point 0, 1. Okay, in order to solve this problem, we just have to, we have the parent function here, and then we have to find the derivative. And so if we, this is the addition, I'm not sure the exact rule, but you can find the derivative separately and add them. So the derivative of 1, or of x is 1, and then of cosine is going to be negative sine. And now that we have that derivative of the parent function, we then plug in the point 0, 1, and we find that we get a slope of 1 if we plug in 0 here, because sine of 0 is just going to be 0, and then we have 1 here, and that will give you a slope of 1 because there's no place to plug in a y value. And then from here, we just have to plug in the original point, 0, 1, using point slope, or y equals mx plus b. And then if we plug that in right there using this formula, so 1 equals 0 times the slope 1 plus b, you find that the b equals 1, and so we have the slope, we have the extra b variable, and so we get the final equation of y equals x plus 1, and that's going to be the answer for that one. And now we're moving on to 4. We have a decreasing function g satisfies g4 equals x and g prime of 4 equals -1/2. Which of the following statements about the inverse of g must be true? So this one, we're going to use a rule that I have outlined right here, I believe. Yes, it's just going to be the derivative of g is equal to 1 over the inverse derivative of g of 4, or whatever number we're looking at. In this case, it's 4. So we just simply plug in the numbers, and we find that g of 4 will, or g prime of 4 equals 1 over g negative inverse of g of 4, and g of 4, as it says in the equation, is 6. So we can plug in 6. So g inverse g prime of 6 is going to be equal to -2, because the 1s on here, they can just cancel out. You can cross multiply up, and it would be essentially g inverse prime of 6 is going to equal -2. And that's the answer that we have right here. All right, and that's all for that question. Moving on to 5. What is the slope of the tangent to the graph of y equals e to the negative x at x plus 2 at x equals 1? Okay, for this problem, I'm just going to take another quick look at the question. Okay, so this is pretty easy. We're just going to be solving the derivative again for this problem. So it's going to be number 5. So we have our parent function right here, e to the negative x, x plus 2. And we find the derivative of that, again using the quotient rule. Because x plus 2 is on the bottom, we leave that one untouched first. Derivative of e to the negative x, you apply chain rule, get -1 minus e to the negative x times the derivative of x plus 2, which is 1, and all over x plus 2 squared. When simplified, that will leave you with -3 e to the negative x minus e to the negative x over 9. And although you can factor out e to the negative x out of this equation, leaving you negative e to the negative x times 4 over 9, that is not a solution on the test. Although that is the right answer. It would be -4 over 9 to the times e. But it was just, I guess, a mistake on the test. But that would be the correct solution for number 5. Moving on to number 6, if x squared y minus 3x equals y cubed minus 3, then at the point -1, 2, dy dx equals, all right, and for this problem, we're going to be finding the derivative of that first equation, and we're going to have to use implicit differentiation here in order to get dy dx, because we have 2 variables here, and we cannot isolate y by itself. So in order to do this, we write the original equation, and then we start solving the derivative. It's going to be, we're going to have to use several multiplication rules here. So for the first one, it's going to be x squared untouched times the derivative of y, which is just dy dx, plus 2x, and that's the derivative of x squared times y, and that's -3, because the derivative of 3x is 3. And then we have that all equal to, we have to apply the chain rule here again. It's going to be 3y squared times dy dx, and then derivative of -3 is 0. And so after simplifying, we move all of the dy dx's to one side and all the rest of the other. We can divide out for dy dx, and then we bring all the extra over to the other side of the equation as such. And then when you plug in -1, 2, which is our point, into the x and y values, we should get dy dx equals -7 over 11ths, which is the correct answer. Moving on, we have this problem. This is one I got wrong because I thought that pi over 2 is 45 degrees. It's not, it's 90 degrees. So if you plug in pi over 2, which is what you want to do to every limit equation, you want to plug it in first, we get cosine of 90 degrees, so obviously 0, over pi over 2, pi over 2, which is just going to be pi minus pi, which is also 0. So in this situation, we can use L'Hopital's rule. I'm not sure if that's how you say it, but yes, so that's what we're going to do. Since this equals 0 over 0, we find the derivative of both the top and the bottom, which is going to be -3 sine x. Yes, and you don't apply chain rule because this is what we plugged in. It's still just x in the parent equation. And then we have, which is just, if you can see it there, pi minus 2x, which should just be -2. And so once we do that, we plug back in the original number, which is pi over 2, which is 90 degrees, which we all know sine of 90 degrees is 1. And so we get -3 over -2, which is equivalent to 3 over 2. And that is the answer for number 7. All right, number 8. This one is relatively simple. It's very similar. If you plug in 2, you get 4, and then you get 0 on the bottom, so we can't use L'Hopital's rule for this one. So what we'll have to do is I plugged in points around it, and you'll find that if you plug in 2.1 or 1.9, it's going to be the same because it's squared. You will not actually have a negative value here, meaning the limit does exist. The limit has to exist because it'll be positive, and we'll find when it gets close, infinitely close to 2 from both sides, it'll be 0.0001 squared. It's plus or minus in between, but then it'll be positive after you square it. And this will just get you positive infinity on both sides of 2, coming from the right and the left. And then we proved that the limit is infinity, which is the correct answer. Moving on to number 9. For this problem, we have f differentiable, f4 equals 7, f prime of 4 equals 1/5. All right, and the graph of f is concave up on the interval through 5. Okay, so use the drop-down menu to create the statement about the approximation of 3.5 using the line of tangent. Okay, so what we're going to do here first, we have to solve for the b value of y equals mx plus b for our estimation. So in order to do that, let's see here. We plug in all that we know. So f of 4 equals 7, so that's our y value. We have the x value, which is 4, and then the slope, which is 1/5, and then we have what we're solving for is b. So if you simplify this all out, you'll get that b is 6.2. All right, and once we have a b, we use the approximation of 1/5 for the slope in order to find 3.5. So it's another y equals mx plus b. Very simple. You plug in f of 3.5, and you get 3.5 is obviously our x value times the slope of 1/5, which is our approximation slope, and then the b value that we found, 6.2, and we get a total of 6.9. 6.9 right here. All right, and that is the answer for 3.5, and this is an underestimate because you'll find when you, I'll draw real quick. My thumb is getting in the way. If you have an equation like that, similar to x squared, the tangent line, gotta make sure I draw this right. Tangent line, whether you go under or over, it's always gonna be a little bit less from that value right there. As you can see, the slope of whatever you're gonna take. If it was concave down, it would be the opposite. It would be an overestimate. But yes, so this will be an underestimate, and that is the correct answer. Moving on to the last few derivatives. We just have to solve for the derivatives here. In order to do this, we can start tackling them. For the first one, y equals root x plus 1 over 3/4, or x to the 3/4 power. So we have that parent function right here. Perfect. So I just rewrote them as powers. We can apply the power rule, and it's pretty simple what I did here. Subtract 1, carry that over. Not sure there's much to explain here. And then I just simplified these, square root x over 2, and negative 3/4, and then obviously negative 7 over 4, which I have here. Actually, that is supposed to be a 7. Yes, so that's my bad. This right here is actually a 7 over 4, I believe. I will double check that real fast. Yes, so I'm glad I caught that. That will be a 7 over 4 there instead of the 3 over 4. Just a minor mistake that I made there. I didn't check my work properly. But anyway, yes, it'll be 7 over 4. And then that will be the right answer for that one. For the next one, y(e) to the x minus, or equals y squared minus 1. We have that equation written down right here. So for this one, we're going to have to apply implicit differentiation, I believe, as well as the multiplication rule. So y(e) to the x, first we leave y alone, and then derivative of e to the x. It's going to be ln e times e to the x times derivative of x, which is just e to the x, which works out really nicely. And then we have dy dx because we're finding the derivative of y, which is dy dx using implicit differentiation, e to the x, because we leave e to the x alone for that one, equals 2y times dy dx, since you have to use implicit differentiation there as well. And from there, I believe that's actually also chain rule, but yeah, we simplify. We bring all the dy dx's on one side like we did earlier with the problem, and then we factor out a dy dx from that side, and then we divide e to the x minus 2y over, and that is actually the solution for this problem. Dy dx equals negative ye to the x over e to the x minus 2y. And on to the last problem here. We have ln 1 minus x. And this from, when I first saw this on the test, I wasn't too happy because I was like, oh man, this is about to trip me up. Okay, but it's not that bad. Y equals ln 1 minus x, so there's just a lot of chain rule here. Ln is the equivalent, so like ln x, the derivative of ln x is just 1 over x. So with that in mind, we have ln 1 minus x is just 1 over this right here, ln 1 minus x, and we have to apply the chain rule to everything inside, so we have to do derivative ln 1 minus x, which is just 1 over 1 minus x, and then we have to do, again, another chain rule. So 3 chain rules in this one, and then it's just the derivative of 1 minus x, which is negative 1, and then all you have to do is multiply all these terms together, and you get negative 1 over ln 1 minus x times 1 minus x. And you can also simplify it by just doing x minus 1 times, let me write this real quick, x minus 1, that's going to be times negative 1, and I'll get rid of the negative there. But both work. That technically is your full solution right there. And that is the full test and all the answers explained. Thank you.